My name is Niole Nelson. I'm a front-end developer. Surprise, surprise. What am I doing here? At Domino Data Lab. I guess you could consider me full stack, but I'm definitely mostly front-end. Domino Data Lab is a startup that enables data scientists to do their work without having to deal with building infrastructure for things like model deployment or model versioning, and enables them to collaborate better through. The infrastructure is built on top of Kubernetes, so if you're interested in that, we are hiring. And so hit me up on LinkedIn. You can find my details on Sched.io. So, right, why are we talking about injecting React into Scala Play? Well, a couple years ago, Domino Data Lab hired me to help modernize their front end in a general sense. And what I found was a kind of just a smattering of technologies. Of course, Scala Play, because the web app's built in Scala Play, which uses a templating engine in order to render its UI, so you can actually stick client-side rendered like JavaScript tools in the Scala Play front end. So that allowed use of things like Twitter Bootstrap and Backbone.js. If I'm sure, well, I don't know. Has anyone heard of Backbone.js? I mean, it's around. Yeah. Okay. Cool. jQuery. Just like a fun patchwork of stuff. A quilt of aging front-end technologies. For example, Backbone's pretty much dead now. I think even the creator said, please don't use this. Anyway, so, okay, great. We have a front end. But there were a bunch of problems with that. So, of course, Domino Data Lab, we have this application. It works. People can get value out of it. They can use this model deployment automation system that we've created, this collaboration system that we've created. But in general, this smattering of front-end technologies created a really poor development experience for back-end and front-end developers alike. This is at the time, when I was a couple years ago when we were it was kind of a disaster. Most of our developers were backend developers. What backend developer wants to write jQuery? That's not what you were hired for. So why are we making you do that? And of course, front-end developers, it's kind of like it was kind of disorganized at the time. Initially, I was hired just to help modernize their stack, but along the way to achieving that, we actually uncovered some insidious problems troubling Domino from a product perspective as well as an engineering perspective, namely poor developer experience and the slowing ability to implement changes according to product vision due to poor technology choices that just kind of accumulated over time. So let's just break it down a little bit, the poor development experience. Let's break it down into a couple categories of disorganized, untestable, and just generally low quality situation. The amalgamation of the jQuery and JavaScript usage and the occasional Backbone.js mini web applications kind of scattered around, and then using a Twitter Bootstrap for the UI along with some CSS contributed to poor development experience. Most generally, there was no core pattern to guide developers when they were adding or updating a feature. This was as much a product of the tools in use as well as how they were being used. Unopinionated libraries like jQuery and JavaScript were the prevailing front-end technologies in some parts of the front end. Rather than being used as spit and glue, they were more like the supporting structures, if you will. As a matter of fact, this entire talk probably would never have happened if the entire front end was written in Backbone. Oddly enough, There are some problems with Backbone, which we won't really get into, but I mean, there at least would have been some structure, you know, some shape to the front end, had that been the case. When you, I don't know if you've run into this, but when you use like, you know, like low level, they're not low level, but you know, low level front technologies like jQuery and JavaScript as the supporting structure, you're really putting yourself at the mercy of your developer's creativity. Which is, you know, don't get me wrong, it's great to express yourself, but you know, it can be it's not exactly always the best thing. I'm sorry, I don't want to crush anyone's developer dreams. So it's a problem because you really have little to no guarantees as pertains to creating an understandable or organized or testable code base. And that's exactly what happened. The lack of organization led to an untestable code base, which was hard to understand, hard to onboard to, hard to change, easy to break, possible only to test with end-to-end integration testing, using browser automation frameworks like Selenium or Phantom.js, for example, which are notoriously it's a notoriously brittle way of testing because it's nearly impossible to get a large production level web application into like a dependable state when you're going through your test cases. Then also, when you don't have good separation of concerns, in this case, the view rendering logic versus the business logic of like sticking stuff in a database or computing information, which will be consumed by the front end. But that stuff doesn't really need to exist alongside each other, you know? So over time, you kind of end up with this, like a massive monolith, like a massive code base, which takes a long time to build, like in CI, or even locally if you're gonna have this like a local dev setup where you pull down like everything. It takes a lot longer when you have to build the back end in order to make it so that the front end can also be compiled. On the other hand, slow product evolution is like a big issue that we ran into. If developers are not properly enabled to do their work, naturally, the product also suffers. When you have a UI with no organization, just like a smattering of JavaScripts everywhere, it's nearly impossible to refactor that into a shared component library. And a shared component library is the basis of evolving your application's user experience in like a sane and timely manner, with minimal breakage and minimal bug fixing. Dependence also on global context for styling, and you know, in the case of CSS, makes product-related changes generally difficult. Dependence on Twitter Bootstrap, if Twitter's in the house. I guess they're one of our sponsors or something. No shade to Twitter, Bootstrap, you know, their Bootstrap library, but if you use like Twitter Bootstrap for all of your styling, you're pretty much married to Twitter Bootstrap. And if you haven't been like working on making some kind of reusable way to share styles or something like that in order to like change the Bootstrap components to like look like what you want your product to look like, then you're pretty much screwed in the long term. And not to mention if you override, you know, if you're basing your entire styling on like a injected shared third-party component library like this, and it's not like you're not being careful about how you're styling it, you're pretty much just making throwaway style changes, which is a big deal if you're trying to like level up your organization from being like, okay, great, we got the MVP, and you want to move on to become like have like a real nice production application where you can iterate in order to improve what you have, in order to support customer use cases, and grow as a company. Ultimately, this stack is not developer friendly. No one wants to work on an application where it's hard to provide value. We all want to be generally productive human beings. Do good things, make something that we're proud of. We want to be able to hire front-end developers who care about the front-end concerns and know how to develop the front-end. And in the Domino case, we wanted to move away from burdening our back-end developers with work that they didn't want to do and we're not hired to do. Also relying on one developer to do full-stack development for all features when you could parallelize the work makes no sense. Especially when you're trying to grow an organization. You know, full stack development is hard, and we want to hire front-end devs to speed up the evolution of our product. So that was our general goal, which led us, so those are all the questions and problems that the problems that we had and the questions we asked ourselves, like how do we incrementally move out of this sticky situation without throwing away everything. So we thought a bit about that, and we kind of decided to come up with some sort of incremental update approach to move to the new paradigm, which should be a front-end, back-end split. The concrete example here, incrementally separating this smattering of JavaScript technologies from our Scala Play backend. Well, from what would be our Scala Play web application, which would be more like an API server, and then which would serve the front end, and also maybe have some nice APIs for CLI use or something like that. So we thought about it for a bit, and given that you're able to execute JavaScript in Scala Play, in the templates, we kind of rolled along and came up with a pattern for injecting React into Scala Play, client-side rendered React into Scala Play. So we're going to talk about how this concrete example solved our problems at Domino, but really you can probably extrapolate this idea to any monolithic web application that you don't want to completely dismantle and rebuild the UI from scratch, but which suffers from the same kinds of problems that we just talked about, like untestability, disorganization, general confusion, and just pain, a world of pain. Okay, so in our example, we've chosen to incrementally move to use React as our front-end framework to solve our problems with the 3 points I just mentioned. And then also to help us move more quickly on certain axes of product development, like trying out new user experiences quickly and quickly enacting application-wide design changes. So in our case, we have chosen to use React because it's general, the opinion that it brings is one of general modularity, which is exactly what we're looking for. So it'll help us create some kind of sane way to do incremental changes, but also build up like a shared library, piece by piece, like from the ground up. But none of it'll be wasted work because we will have created something that's shareable and that we can take with us and evolve without spending too much time on it. Ultimately, the reason why it'll work from a technological perspective is because React, so when you see like docs or examples of React with the JSX syntax, well, that's just all syntactic sugar. And we have all these technologies in front-end land, in the NPM ecosystem, all these packages that are used that serve the purpose of transpiling this JSX syntax down into just plain old JavaScript, which we can stick right into the DOM because we're quite lucky that browsers can read and execute HTML and then know how to download and execute JavaScript. So that's our secret weapon in this case, and that's what will make it so that we can use React in the Scala Play template. Also, it's opinionated, will give our developers some structure, and it'll attract front-end developers for our company. That's a win. It has a large ecosystem with lots of conventions surrounding it for testing, for developing UI components in isolation. So, meaning you don't have to deploy your application in order to develop these individual components. We can use this wonderful tool called Storybooks, if you've heard of it. So, like, say I'm making a new modal. I don't have to, we have this little toy server that we can use to develop this modal. We don't have to serve up our application and go to the right page in our web app in order to look at it and iterate on it. And also, React is officially type-safe, and with the introduction of TypeScript, in the past couple years, it's become a lot more mature, and it's totally production ready, and it's honestly, like, takes a huge burden off of you psychologically, that you don't necessarily have to just like click through every time you touch a piece of JavaScript, you don't have to like click through every single workflow in order to make sure you're not going to get fired tomorrow when you merge this. Honestly, the other day I was for fun I was just creating a birthday card website for my friend for her birthday, and I was like, oh, this will be just so fun. I'll just like inline the JavaScript and I'll just inline the CSS and I'll be all fine. And then JavaScript just lies to you. It's like, okay, I'm gonna run now, and then it just like, you're like, what happened? It didn't, nothing's working. So use TypeScript. All right, so React, it's opinionated. Thank goodness. React, you can kind of, when we think of React, I don't know any of you guys, I don't know what your experience is with React, so we're just going to assume that you've seen pictures of React components occasionally in like Hacker News. And that's what I'm going to assume for you guys. So you can make a React component. The great thing about React components, though, is that, so they're modular. You can also render more React components inside of each React component. So ultimately, you actually end up with like a tree of React components, which is kind of lovely in itself. One of the great things about it is this idea of unidirectional data flow. So assume this abstract representation of this tree of React components. Let's just pretend it's like a drop-down. The root node is the entire drop-down. But then some of the nodes below it, maybe this one on the left with no children, it's like a button for opening the drop-down. And then like on the right side, like that's just the drop-down part with all the, the list elements. So kind of nice to think about. So that was just to help you center yourself in this tree diagram. So anyway, the great thing about React is that it's unidirectional. Its data flow is unidirectional, so that makes it a lot easier to debug when you have a problem, especially if you're not using TypeScript, but you're going to use TypeScript. So, back when we just had JSX, this was like life-changing. Anyway, so it's because the unidirectional data flow exists, it's easier to conceptualize what should happen given your data looks a certain way. So say your state that comes in at the top of the tree looks a certain way, you can kind of just extrapolate out what everything else should look like, because nothing's like sending events to random places, and which may be caught somewhere else, but you don't know, because it's just kind of one of those concepts where the event goes out into the ether and gets caught, I don't know. And yeah, so it's not easy to follow. There's no like stack trace to follow that kind of pattern of eventing. So this automatically makes it better than Backbone.js, where you can have like bidirectional event emitting infinite loop nightmares, where like, you know, in Backbone.js you can emit events. They can get caught, and then that event can get caught by something else which emits an event. And then maybe that gets caught by the place that emitted the original event, and then you're just going like, you know, infinite loop nightmare. So you won't get that with React. If you don't add anything crazy, of course, you know, just by itself. That's the way it is. Better than jQuery, which has no opinion about data flow. And it also provides an elegant grokable structures for developers to model their applications with. So in general, the recursive structure of a React component tree is quite nice to look at and think about, in my opinion. Each subtree in the React component tree represents a chunk of the view in your application. And the entire tree is a web page, but as you drill down into the tree, you know, one subtree is a drop down, another is a button, another is some kind of like sub view. Lots of fun. And you can even have, because we have the tools to transpile React down into just plain old JavaScript, you can have actually several independent React component trees on a single HTML page. So that's something we're going to take advantage of in our injecting React into Scala Play idea. And then, which will, you know, help us evolve our front end away from our back end and eventually into a separate server. So if you keep your data flow as pure as possible, you know, if there, you know, where you keep all of your I/O and all that stuff at the root of your tree, and you keep everything, you know, basically, the idea here is that your DOM, whatever is rendered in the DOM, is a direct representation of the data that you supplied. So it's just inputs to outputs. Your life should be simple. And it can be. And it is with React if you don't do anything insane. Like adding random event emitting, but I don't know why you would do that. Because that'd be weird. So if you keep your data flow as pure as possible, if there's a runtime error, like we've modeled here, despite the large number of React component nodes, there's actually quite a short pathway to investigate in order to understand the origin of your bug. It's also performant. The idea is that if every operation you were to do were to actually touch the DOM, that's actually quite a computationally intensive operation for your browser. But if in the case of React, it uses a thing called virtual DOM, which I'm sure you've heard about. It's the hotness. I don't know. It's popular. Yeah, you know, we hear there's some words you hear over and over again. I guess and virtual DOM is one of them. And the idea is that if you just keep the representation of your DOM in memory, like as a string or something, that's actually a lot, and then only apply the actual changes to the DOM. That's going to be way more performant than performing unnecessary updates to your DOM all the time. And then here's in case anyone hasn't seen TypeScript yet, this is evidence that it's real. It's actually here, and you can finally get like insight into whether your data that you are providing to your React component, in the case of this item, is actually of the shape that it should be. So for a long time, you know, we would get by with just linting, and linting is great. It'll let you know if you've got a variable that isn't defined anywhere but you're attempting to use. That's pretty important. But eventually that's really not enough. But that does keep out a certain class of bugs. But ultimately, it would be so much better if we knew for sure that the shape of our data was correct when we supply it. So I know some of you are probably thinking, like, why aren't we talking about Scala JS? React, come on. And I totally get it. Or GHC JS, that would be lots of fun to use in a front-end web application. I agree. But in all fairness, you can probably come up with an approach that works for you with any framework that will eventually compile to JavaScript, which would allow you, and that would allow you to separate your front end and back end just fine in this particular situation. So yeah, go for it. Depending on what your overall goals are, Scala JS, GHC JS, that they may get you there. But in my case, I know there is an ecosystem around React JS, which enables a certain profile of typical JavaScript developer, and I know that certain tools exist that will be so helpful to us to develop quickly, address product requirements quickly. So the decision to use React here, yeah, I like React a lot, but it's as much a strategic decision, a business decision as anything else. So all right. So let's get into the implementation for how we are actually going to do this. How are we actually going to separate our backend and front end? How are we actually going to enable these faster build times? So let's get into it. So the magic all boils down to two things. Reverse proxying, and taking advantage of the fact that when you're writing a web application, no matter what, you will ultimately be executing JavaScript in HTML in a browser because that's how it works. In our case, the role of the reverse proxy is to allow us to split the front end into its own server, which can have like hot reloading in dev mode, super important, and then in prod, depending on your setup and whatever your limitations are, you could, or probably also depending on your relationship with your platform team, you could bundle the JS asset with the main application in prod, or have it served as a static asset on your separate node server, which would be proxied to in order to maintain the current user experience for your end users. And the setup would look something like this. You've got your Chromium, your new Chromium style Internet Edge Explorer web browser over here. User opens up their cutting edge Microsoft new Edge browser, and they decide to look at your application's homepage. They hit /home, and a reverse proxy intercepts this request, and it sends it, in this case, to our Scala Play application, which knows how to, which responds with like the template, which represents your homepage. And the homepage happens to have some script tags in it, some of which reference our vanilla JavaScript and CSS assets, which are our like shared React component library that we are creating. So when those script tags get executed, the browser will then send some GET requests to /assets, blah, blah, blah. That'll get routed through Nginx again, but in this time it'll be sent to your webpack dev server where you're doing JavaScript, and which is serving your bundle, your JS bundle and your CSS bundle, or whatever you want, really. I mean, it's just a little server. So in dev, hot reloading has source maps for debugging. In prod, assets are compressed. You could really do anything with this tiny little JavaScript server. In any case, the user experience is preserved, but we're inching closer to our goals with front and back end separation. All right, so what are we going to do? How are we going to get the JavaScript into the Scala Play template? We're going to create a helper utility, which is going to be able to reference our shared component library and just make it available so it can be mounted in HTML. And this is, so like in practice, the use of the injection helper is going to look a bit like this. You've got your reference to your bundle, which is, we're going to be proxied to the correct server in order to get the correct assets. And our component library is going to expose this global variable called component library on the window, and it's going to have a little helper function on it, which takes some important specifications like what's the name of my component and what are the props and what node should my React component be mounted to. So you can have you can specify where your React component goes, where it gets used. And then this is the internals. It's really quite simple. We go and we've got some sort of import called all components, and we go and get the component based on what the name is that was supplied, and then if it exists, we just use a React DOM to mount it in the place that we expected. And I got some code all written up. We're probably not going to go through it, but I'll post my slides on Sked.io. So if you want to go follow the links, that'll be you can do that. And there's a I'm gonna be great. If and I have a little demo running, but I'm totally mind blown by this two screen setup. So I don't know. I probably can't figure that shit out. So here's the evidence that it actually works. Here's a tiny little application. We've got our Nginx configuration running. It's and we're looking actually at a page served by a Scala Play web application. With some things in play, as you can tell by that string up there, that part's in play. But then these tabs, they're rendered by a separate server, which the reverse proxy proxies to, so that we can access those assets. All right, and that is that. That's how you do it. Thank you for listening.
Thanks, Niole. Any questions?
Yes.
So if you asked me the question, that's obviously a question, why not Scala.js? But let me ask you, sorry, you had originally said, why not Scala.js, and you answered right. But so my question is, why not React on Scala.js?
Oh yeah, I know, that's a thing. Yeah, you should do it.
It's done.
I didn't get a chance to use it, but I've seen the syntactic sugar looks nice and fun, and apparently the concepts are all there. So, yeah.
So and it's getting better. I'm actually in a project that we're making lots of progress to make even more wrappers around it.
Oh, cool.
So if you want to talk about it afterwards.
All right. Yeah, sure. That'd be a cool thing.
Any other questions for Niole? All right, thanks a lot.
Thanks, everyone.